Hey there, Precalc kids. Today we're going to finish up 1.2. We're going to call this 1.2c, asymptotes. Okay? And we're going to learn about horizontal, vertical ones, maybe do a little bit of boundiness, all that good stuff. Okay, it should be quick. I shouldn't say that. It'll probably be long-winded, and we will all survive. Let's talk about asymptotes. Okay, the line y equals b is a horizontal asymptote of the graph function y equals f of x if f of x approaches the limit of b at x squared. What you guys need to understand is this is your horizontal asymptote. Okay, and what this says, you can't really see it down here, as x approaches infinity, f of x equals b. So that'd be like if you have a graph like this. And as this goes off to infinity, it gets close to but never touches, you know, a certain value, like this value, like 5. Your asymptote of this would be 5, because it gets really close to 5 but never crosses it as it goes off to infinity. This is just different notation. Your limit as you go to infinity is 5. It's going to get really close to it, but not touch it. Okay. Your vertical looks a little bit different. What this one says, as x approaches a from the negative side, and as x approaches a from the positive side. What that says is, as you approach some value, a, as you get closer and closer to it, you go off to infinity or negative infinity, or both. Okay, so as you get close to a, you get closer and closer and closer, you zoom off into into infinity. Okay? So that's a vertical asymptote. You guys have probably seen this before, and you're probably thinking, why in the world are you teaching us this crazy limit stuff with it? Because you're going to see it in calc. And this is pre-calc. Pre before calc. No. Okay, going forward. Let's do an example. Okay, I don't know why I worked this one out, but I did. This is really important right here. Really. We're going to find all the vertical and the horizontal asymptotes of x squared plus 2, all divided by x squared minus 1. Okay? First step, we're going to find the vertical asymptotes. To find your vertical asymptotes, you set your denominator equal to 0. Okay? And you solve. So that's where we get x squared minus 1 equals 0. Add 1 to both sides. So x squared equals 1. Now remember, when you square root both sides, you have to do plus or minus, right? You have 2 answers. So you have 2 asymptotes at x equals 1 and x equals negative 1. Okay? So if I were to draw a graph at 1 and negative 1, there's going to be asymptotes, right? That's what it means. At x equals 1, x equals negative 1. Now for a horizontal asymptote, here's what you're going to do. Way 1, you can graph it, which I already did. Use trace. Uno, dos, trace. Okay, and go all the way over here and see what value you get really close to. And for this one, you find out that it's at y equals 1. Okay. The other way to do it is you look at leading coefficients. Okay. What I mean by that is you have a 1 and a 1. These are both the same power, right? You take your leading coefficients, which is 1 over 1. So that tells you that y equals 1 is your horizontal asymptote. Okay? So that's it. That's all there's to it, guys. Sidebar. Sidebar. So if you had something like 3x cubed plus 2x squared over 5x to a third, and you're looking for a horizontal asymptote, it'd be at y equals 3/5. Okay? Leading coefficients, if the powers are the same. If the powers are not the same, graph it and you'll get a good idea of what's going on. Let's try another one. Find the domain and all the asymptotes of this function. Okay. Now, we know for a domain, we need to take our bottom and set it equal to 0, right? So we get x squared equals -9. And then we go to take our square root, and we get not a real number. So our domain is not restricted. Our domain is not restricted. So it's all real numbers, from -infinity to infinity. Okay? So now our asymptotes. So we take a look for our horizontal. Here's what we do. I'm sorry, what this means is we have, since this is all real, there is no vertical asymptote. Okay? Because x squared plus 9 does not equal 0. Okay? Now for a horizontal asymptote, we take a look. These powers are not the same, right? So here's what happens. If your numerator's degree is less than your denominator's degree, then your horizontal asymptote is y equals 0. Okay? And that's if your numerator degree is less than your denominator degree. Okay? Take my word for it. So if they're equal, use leading coefficients. If your numerator degree is less than your denominator degree, use your just y equals 0. And if your top degree is bigger than your bottom degree, you're going to get a slant asymptote, which we don't talk about yet. So just hold on to your horses on that one, okay? Right now you're going to get y equals 0, or y equals a number, or you don't worry about horizontal asymptote. It doesn't have one, okay? Okay. That button doesn't work. Okay. Boundedness, I just want to show you this. Don't worry too much. This is an example of something bounded below. It has a lower asymptote. I know why I'm showing you guys this. I did want to show you something interesting to think about that will come up in calc. If something's bounded by its domain, what that means is you don't have a full graph. It doesn't extend throughout the entire Cartesian graph, right? And what that is because it's bounded by the domain. And this is one where your domain is -1 to 1, right? Because you can't take square root of a negative number. We're dealing with real numbers here. So because your domain's only -1 to 1, you can only graph from -1 to 1. So you're bounded by that domain. It's kind of neat, something to think about when you start doing calc. But that's all I'm going to leave you with. Enjoy.